Assalamu alaikum. I am going to discuss on assignment problem. Assignment problem is a special type of transportation problem where each source must be matched with a destination, but each task must be assigned to a worker who has the required skill. The objective of assignment problem, the objective is to minimize the cost or time of assignments, particularly when job assignments involve multiple operators, is with varying time or cost. So simply we can say that the assignment problem involves pairing tasks or jobs to workers or operators such that the total cost or time is minimized. Now see that here the mathematical model of our assignment problem, and this mathematical model formulated using a 0-1 programming model, and this model assigns a 1 if a job is assigned to an operator and a 0 if it is not. In this formulation we identified that that means M represent that the number of row, that means jobs, as well as the number of columns, that means operators. Cij, it is the time or cost, processing time or cost of assigning job I to operator j. And xij, this represents the binary decision variable, 1 if assigned and 0 otherwise. Now we'll go for the discussion regarding on types of assignment problem. Assignment problem basically two types: balanced assignment problem and unbalanced assignment problem. Balanced assignment problem, there are the equal jobs and equal number of jobs and equal number of operators, and this is the most straightforward case. And unbalanced assignment problem, that means the number of jobs does not equal the number of operators. So in this case we use dummy job and operators to balance this system. Now it is the question how we can solve this assignment problem. We can solve this assignment problem by using Hungarian method. So Hungarian method is an algorithm designed to effectively solve the assignment problem. So Hungarian method is a combinational optimization algorithm used to solve the assignment problem in polynomial time. And this assignment problem or when we use the Hungarian method in this assignment problem, we identified that it is the most popular method. This Hungarian method is widely used in industries and academic fields required optimization and resource allocation. And also it has been adapted as the standard solution for assignment problem in various applications from scheduling to transportation logistics. In our Hungarian method, it involves the following or specific three phases. Number one here, row reduction; number two, column reduction; and number three, optimization. But we can subdivide that into various steps. That means step one, row minimum and row reduction. That means at first we try to identify the smallest element in each row, and for each row subtract the smallest elements from our every other elements in the same row. This is the row reduction. And another performance here, our column minimum and column reduction, that means find the smallest element in each column, and for each column subtract the smallest element from every other elements in the same column. And step 3 here, draw lines to cover all zeros. That means simply we can say that draw minimum line to cover maximum zeros. Then step 4, optimization. If optimality found, we can say that this solution is optimal, but if not, then we'll go for step 5, that means find the smallest uncovered element, add it to the intersecting elements, and subtract it from all uncovered elements. Covered elements remain unchanged. Now we'll go for the example regarding on this Hungarian method. So this is an example. So how we can so calculate this, or how we can solve this. So we start from our step 1, that means row minimum and row reduction. So at first we'll try to find out the smallest element in each row. So see that here, it is the row minimum. So row minimum here, see that find the smallest element in each row. So first row, the smallest element here 8, second row smallest element 7, third row smallest element 7, fourth row smallest element 10, and fifth row smallest element 8. Then we will go for another operation, that means row reduction. That means, and for each row subtract the smallest element from every other element in the same row. So we can calculate this in our table 2. We can write it here, row reduction. So row reduction, see that here, that means for each row subtract the smallest element from every other element in that same row. So we can calculate here. So if we subtract 8 from all other elements of row 1, we can identify here. That means after subtraction, we find here 10 minus 8, it becomes 2. 12 minus 8, it becomes 4. 15 minus 8, it becomes 7. 12 minus 8, it becomes 4. And 8 minus 8, it becomes 0. Same application for our job 2 or row 2. That means we can subtract this minimum value from all other elements or all other values of row 2. That means 7 minus 7, it becomes 0. That means 16 minus 7, 9. And 14 minus 7, 7. 14 minus 7, 7. And 11 minus 7, 4. And for row 3, the minimum value here 7. Now we can subtract this 7 from all other element of row 3. So 13 minus 7 is 6. 14 minus 7, 7. 7 minus 7, 0. Then 9 minus 7, 2. 9 minus 7, 2. Again, for row 3, the minimum value here 10. So we can subtract it from all other elements of row 4. 12 minus 10, 2. 10 minus 10, 0. 11 minus 10, 1. 13 minus 10, 3. And 10 minus 10, 0. For row 5, the minimum value here 8, so we can subtract this 8. We can subtract this from all other elements of row 5. So 8 minus 8, 0. 13 minus 8, 5. 15 minus 8, 7. And 11 minus 8, 3. And 15 minus 8, 7. So then we'll go for step 2. That means column minimum and column reduction. That means find the smallest element in each column. So we can calculate here or find here column minimum. First column minimum value here 0. Second column minimum value 0. Third column minimum value 0. Fourth column minimum value here 2. And fifth column minimum value here 0. So another function here, column reduction. That means for this column, subtract the smallest element from every other element in the same column. So we can perform this. So we'll go for table 3. That means column reduction. Column reduction. Now we can subtract the minimum column value from all other elements of that column. So see that here first column minimum value here 0. So if we subtract this from all other elements of column 1, we can find that the same things. So we can write that here 2 0 6 2 0. Same thing for column 2, the minimum value is 0. So if we subtract this from all other elements of column 2, we find here 4 9 7 0 and 5. And same things for column 3 7 7 0 1 7, because the column minimum here 0. But in the column 4, we find that the minimum value here 2. So we can subtract this from all other elements of column 4. So we can find that here 4 minus 2. 4 minus 2, it becomes our 2. That means 2. That means 7 minus 2. That means 5. 2 minus 2 0. 3 minus 2 1. 3 minus 2 1. And column 5, we can find here the minimum column value here 0. So if we subtract this, it will unchanged. So we can write that 0 4 2 0 7. So see that here we already completed our step 2, that means column minimum and calibration. Now we'll go for step 3, draw a line to cover all zeros. So otherwise we can say that is the, on the other hand we can say that is the draw minimum line to cover maximum zero. Draw minimum line to cover maximum zero. That means we start from the maximum zero, where located the maximum zero, or another way you can say that we can draw a line from where maximum zero locates. Okay, so first of all we try to track that row 1 there is only 1 0, row 2 there is only 1 0, row 3 there are 2 zeros, row 4 1 there are 2 zeros, and row 5 1 0. So maximum zero we identified here in row 3 and row 4. For column 1 there are 2 zeros, column 2 there are 1 0, column 3 there is 1 0, column 4 there is 1 0, column 5 there are 2 zeros. So in our column we identified here the maximum zero here 2, and this in column 1 and column 4. So we can start drawing from line drawing from row 3 or row 3 or row 4 or column 1 or column 5, from anywhere. Okay, fine. So we can start from this. We can start drawing the line from here. So we can start from row. So see that here row 3 we can draw here this line. Okay, fine. Then again we can draw the line, another line from our to cover the maximum zero in row 4. Okay, now again we can check that row 1 there is 1 0, row 2 there is 1 0, row 3 row 4 nil, row 5 there is 1 0. But in column 1 there are 2 zeros, and in column 5 there is 1 0. So now we can draw a line in column 2, because this column 1, because this column 1 contain the maximum zeros. And finally we identified here only 1 0 in column 5 and row 1. So we can draw line to cover this 0 from column column 5 or row 1, from anywhere we can draw this. So for capturing or to cover this, we can draw line in column 5. Okay, so we can complete our another step, step 3, draw line to cover all zeros. See that here we Draw the line to cover all zeros. Okay, fine. Now come to the point to check the optimization. Step 4. If the number of line equal to the number of jobs or operators, the solution is optimal. And this solution or this problem is our balanced assignment problem. That means 5 rows and 5 columns. That means equal number of job and operators. So in this case, the optimization depends on the number of line and our row or column number. See that here we draw here 1, 2, 3, 4. So the draw line number is equal to 4 and the row or column number is the 5. So we can say that it's not equal, so optimality is not found. So we'll go for the step 5. That means find the smallest uncovered element from this table and add it to the intersecting element and subtract it from all uncovered element. Covered elements remain unchanged. So we can perform this. Other things, our table 4. And this table 4, we can say that it is the redesigning. We can redesign this. Okay. So see that here we can perform this here. Our at first we can remove this for our better calculation. Now we can start from row 1. So see that here this row 1, 2 is the covered. So see that here the direction covered elements remain unchanged, but we can add this smallest uncovered element. That means see that here the smallest uncovered element is 1. So we can highlight this through red color. So we can see that this is our smallest uncovered element. We can add this smallest uncovered element with the intersecting elements, and these are the intersecting element 2062. So we can add 1 with this intersecting element, and we can subtract it from all uncovered elements. So we can subtract this from our all uncovered element. That means 4, 7, 2, 9, 5, 7, 5, 7, 1. These are uncovered elements. So we can subtract this 1 from all uncovered elements. But see that here covered elements remain unchanged. So see that 2, 0, 0, 4, 7, 0, 0, 0, 1, 1, 7, 0. These are covered element, and this covered element remain unchanged in our calculation or redesigning table. So we can start our calculation. As for row 1 is the covered, so unchanged. For uncovered, so we can subtract this 4 minus 1, that is 3. 7 uncovered, so we can subtract 1 from this 7, so we find it 6. 2 uncovered, so we can subtract 1 from this 2, so 2 minus 1 is equal to 1, and 0 is the covered, so this unchanged. Okay. For row 2, 0 here covered, so unchanged. 9 uncovered, so we can subtract, so 8. 7 uncovered, we can subtract 1, so 6. 5 uncovered, so we can subtract 1 for 4, and 4 covered, so unchanged. For row 3, 6 intersect, so we can add 1 with this 7. 7 uncovered, 7 covered, so unchanged. 0 covered, unchanged. 0 covered, unchanged. 2 intersecting, so we can add 1 with this intersecting element. And for row 4, 2 is the intersect, so we can add 1 with this intersecting element 2, and 0 covered, unchanged. 1 covered, unchanged. 1 covered, unchanged. 0 intersecting, so we can add 1 with this intersecting element. For row 5, 0 covered, unchanged. 5 uncovered, so subtract 7 uncovered, so subtract 1 with this, and 1 uncovered, so we can subtract 1 with this, and 7 covered, so unchanged. So After performing this, we'll go for, see that here, we'll go for step 3. That means continuing the iteration from our step 3. That means draw line to cover all zeros. Now again, we can draw line to cover our all zeros. So we can start from the maximum zeros. So we can say that draw minimum line to cover maximum zeros. So now we'll go for that, for drawing. So see that here, row 1 contain 1 0, row 2 contain there is 1 0, row 3 there are 2 zeros, row 4 there is 1 0, row 5 there are 2 zeros. So in row we identified here maximum 2 zeros, and it's located in the row 3 and row 5. For column 1, there are 2 zeros, column 2 1 0, column 3 1 0, column 4 there are 2 zeros, and column 5 there is 1 0. So in column we identified that column 1 and column 4 containing 2 zeros. There are 2 zeros in column 1 and column 4. So we can start from row 3 or row 5 or column 1 or column 4. Okay, because there are 2 zeros in row 3, row 5, column 1 and column 4. So we can start from anywhere, row 3 or row 5 or column 1 or column 4. Okay, so we can start from column 1. Okay, we can draw this line. Again we can draw this line for covering the maximum zero of column 4. Again we can check that row 1 there is 1 0, row 2 nil, row 3 there is 1 0, row 4 there is 1 0, row 5 nil. Column 1 nil, column 2 there is 1 0, column 3 there is 1 0, column 4 nil, column 5 there is 1 0. So 1 0, that means we can draw uh, line from anywhere, that means from row or from column, anywhere we can draw this line to capture or to cover this zero. So we can draw this, see that here we can draw in column. So we can draw one line to in column and another for capture 0 in column 3, and draw another line in column 5 to capture 0. Okay. So see that here, now we'll go for the optimization. If the number of line equal to the number of job or operators, the solution is optimal. So see that here, drawing draw line number 1 2 3 4 5. So we can say that the draw line number is equal to row or column number. So we can say that this table is our optimum table. So we'll go for decision on that table. Okay, so we can make here a decision table, or we can draw here a decision table for taking our decision. Okay, so decision table contain here three important columns. That means first column related with the job, that means this job row. Second column contain the columns, that means this column here operators. And third here cell. This cell represent the processing time. So first of all row, see that here row 1, that means we can say that this row first column contain the row, that means jobs 1 2 3 4 5. There are 5 jobs. Now we can choose the operator for these jobs. How we can choose this? So see that in our optimum table or optimal table, we can select 0 randomly from each row and column. So again we can say that we can select 0 randomly from each row and column. That means only one zero we can select from each row and column. There is no overlap is allowed in this process. So from first row we can select this 0. Second row we can select this 0. Third row we can select this 0 randomly. Fourth row we can select this 0, and fifth row we can select this 0. So we can fill fill up this column on the basis of our selection. That means first row we select here 0 from column 5. So we can write here row 1 column 5. For row 2 we select 0 from column 1, so we can write that here row 2 column 1. And row 3 we select here we select 0 from column 3, so we can write that row 3 column 3. Row 4 we select 0 from column 2, so we can write that column 2 for row 4. And for row 5, that means job 5, we can select 0 from our column 4 or operator 4, so we can write it here row 5 column 4. Now we can fill this column, that means cell, that means processing time, cell and processing time. So row 1 column 5. Now we'll go for our main problem here. That means row 1 column 5, row 1 column 5 contain, that means see that what was the element, what was the processing time. Row 1 column 5, see that 8, so the processing time was 8, so we can write that here row 1 column 5, the processing time or cell entry is here 8. And row 2 column 1, so row 2 column 1, in our beginning table row 2 column 1, see that here the processing time 7 or cell entry is 7, so we can write that 7. And row 3 column 3, row 3 column 3, see that here row 3 column 3, here cell entry 7, so we can write that 7. And row 4 column 2, row 4 column 2, row 4 column 2, the cell entry here 10, so we can write that 10. Again row 5 column 4, row 5 column 4, there cell entry here 11, so we can write that here 11. Finally we can add this all processing times, and after that we identified here the minimum or total minimum processing time for accomplishing these 5 jobs with 5 operators, and these are the total minimum processing time. So this is the completion of this problem. Thank you so much. Assalamu alaikum.